Hi guys, welcome to another episode of MrLopezClasses.com. This is our diesel engines class. This is the chapter 3, episode 3. In this chapter we are going to talk about the parts of a diesel engine, the components of a diesel engine, and in the second part of the video we are going to talk about the organization of the block, inline or V or flat, and the number of cylinders per each bank. Now we are going to check the diesel engine components. The first element is the block of the engine and the head gasket. The second component, the block, is the most important part. Right now we are going to check in details what happened in the blocks, and we have a chapter dedicated exclusive to study the blocks, the cylinders, the different type of cylinder liners, and the procedure to replace the cylinder liners. This is other chapter. Today is basically the basic concepts about the composition of a diesel engine. The second part is the head. The head is bolted over the block in order to close the cylinders. On the heads, right now we are going to check are the valves and the rocker arms and the training valves. We are going to do a project. We are going to repair a head valve completely. The head valve is covered by the valve cover. This is the valve cover. The valve cover. In the bottom, the block is connected with the oil pan, and the oil pan with the seal, the gasket, is bolted directly on the block. On the head in one side, we have the intake manifold. In the other side, in the other ports, we have the exhaust manifold. This is the exhaust manifold, and this is the intake manifold. Each manifold enters in one side of the head. All the heads, they have in one side the intake manifold, and in the other side the exhaust manifold. If you check through these ports, you see the exhaust valves, the body of the exhaust valve. If you see through the other ports, you see the body of the intake valves. Right, you have intake manifold here and exhaust manifold over there. Okay, in the intake manifold, normally you have located the throttle body, and over the throttle body is located the air filter. This is normally at the intake manifold. All right, in the exhaust manifold, normally you have connected the turbocharger. The turbocharger is connected in the exhaust manifold. Other component that we have in a typical diesel engine is the fuel injection pump. The fuel injection pump, the gear of the fuel injection pump, engage with the gear of the crankshaft and the gear of the camshaft that I am going to explain in the next slide. All right, the fuel injection pump is connected directly with the injector. Each injector is connected with the fuel injection pump. This is the main components. And finally, the oil filter. The oil filter is bolted directly on the block in order to filter the oil during the movement of the oil through the block and the head. All right, in the next slide, we are going to check a little more details the block. The block of a diesel engines normally have two different types of cylinders: dry cylinders or wet cylinders. The dry cylinders are inserted permanent on the block, and the wet cylinders are removable. You can replace those wet cylinders and you can replace those cylinders. This is an advantage because if you have a problem in one cylinder, you can replace only the sleeve of that particular cylinder, and you can fix it only one cylinder. This is a good advantage. For that reason, 90% or more of the marine diesel engines, they have wet sleeves. Those sleeves are wet sleeves because the coolant is surrounding the sleeve in order to keep lower temperature. This is excellent. All right. In some cases, the camshaft is part of the block. In the previous slide, the camshaft was on the head. Depending on the design, in some cases, the camshaft is part of the block. In some cases, the camshaft is part of the head. This is not a problem because at the end of the day, with the gears, the camshaft and the crankshaft are connected together. And this is the crankshaft. The green is the crankshaft. The blue one in front, this is the harmonic balancer. And this one, the red one, this is the flywheel. In other words, this system, crankshaft, harmonic balancer, and flywheel, they work together. For that reason, in the chapter dedicated to the crankshaft, I am going to explain the procedure to do the dynamic balance on the crankshaft. We are going to send the crankshaft with harmonic balancer, with flywheel, with bearings, and with connecting rods, with pistons, with piston rings, with bearings of the connecting rods. All of those elements together, we are going to send into the machine shop in order to do the dynamic balance. This is an important step in the process of reparation of a diesel engine. All right, the crankshaft is bolted in the bottom. Is bolted in the bottom of the block with the flywheel, with the harmonic balancer, and the pistons. The pistons are moving inside of each cylinder. And of course, the crankshaft is connected with the camshaft with the camshaft gear, and the crankshaft with the crankshaft gear. Both of them work together with other gear. In a typical diesel engine, you have the crankshaft gear, the camshaft gear, and the fuel injection pump gear working together. They are working together, and they should be aligned with those marks. Those marks should be aligned in order to put the engine on time. Yeah, this is a special mechanical fuel injection pump in line. In the previous slide, we have a fuel injection pump rotary. There are different types of fuel injection pumps. We are going to study later each type of fuel injection pump. This is a mechanical fuel injection pump inline, and the gear of the fuel injection pump engage with the gear of the camshaft and engage with the gear of the crankshaft in order to put the engine on time. This is the process that I am going to explain at the end of the chapter dedicated to the crankshaft. I am going to explain the procedure to put the engine on time. And okay, the other part of a diesel engines are the secondary filter, fuel filter, the primary filters or Raycor-Parker filters, the fuel transfer pump. This is a 12 volts or 24 volts pump. And let me check another component. All right, in some engines, the fuel injection pump is not mechanical, it's electronic fuel injection pump. And the electronic fuel injection pump receives the signal from the computer or ECM. The computer is connected with the harness of the engine, and each pin in the computer is dedicated for one specific element. The red one in this particular case is for the fuel injection pump. The blue one here is for the solenoid. The other one is for the injectors. This is the ECM. This is a diesel engine with electronic control module or electronic fuel injection. This is a specific diesel engine with a common rail fuel injection. We are going to learn that procedure. And in this particular case, the timing is only between the camshaft and the crankshaft. The fuel injection pump don't need to be connected on time with the system. We are going to talk later about that situation. All right, this is those are the main components of a typical diesel engines. And we are going to study in details each of those elements and how they are connected in the engine. For example, in this particular case, I have the head, and I have the exhaust manifold here and the intake manifold here. All right. If I have a turbo, the turbo is connected here. This is the hot side of the turbo. and the shaft of the turbo is connected with the cold side of the turbo, and the cold side of the turbo enter into the intake manifold. This is the turbo, that turbo, and this is the procedure to connect the turbo. We are going to talk later about that. This is the typical components of a diesel engine. Cylinder arrangement. How the cylinders, how the block of the diesel engines are organized. The most common type of cylinders, the organization of the cylinders. Common cylinder arrangements are from 6 cylinders into 16 cylinders in inline or a V configuration. In this particular case, in the first example, I have a configuration that is 4 cylinders, straight 4 cylinders inline. In the second configuration is a V configuration. In this particular case, it's a V6 engine, but there are VA, V12, and V16. A lot of Detroit diesel, they are very common in V12 and V16. This is the most typical configuration. Or other type of configuration is the flat configuration. The inconvenience of this design is the friction produced here with the cylinder. This is the typical design used in Volkswagen and Porsche. The flat configuration is very common in aviation because the space is less space because it's a flat configuration, but it's also common in automotives, Porsche, Subaru, Volkswagen. The Volkswagen Beetle, if you remember, have that configuration, flat configuration. It's not common in marine applications. Other type of this is another example of the flat configuration, and the problem is the excessive wear because the friction in that point is critical. This is the flat configuration. It's not common in marine applications. In other type of configuration, this is the most common, the inline configuration and the V configuration. Very, very common in marine applications. And this is the rotary, the radial engines, very common in aviation. And the verticals opposite is not common in aviation, in marine. In marine is only common the number 1 and the number 2, inline or V. The V configuration is used when the space in the engine room, the height of the engine room is not enough. The V configuration is better. The inconvenience of the V configuration is the engines are wide in comparison with the inlines. The inlines engines are narrow engines, but they are a little higher. When you select the engine, I am going to explain the procedure to select the engine. I explained in the class of intro the procedure to select the engine. You need to take in consideration the space that you have in the engine room, the height, the width, the dimension of the engine room, and you need to take in consideration the distance in between the stringers. According with the distance in between the stringers, you can select the engine appropriated in different manufacturers. That's the procedure. You remember the procedure to calculate how many horsepower I need in that boat. All right, this is the formula. You divided the total weight by 500, and you found it the total amount of the minimum horsepower required to move the boat at the maximum hull speed. All right, this is the configuration. A straight engine. The cylinders are arranged in a line, in a single bank. The straight engine or inline engine is an engine with all the cylinders aligned in one row, with no minimal offset. All the cylinders are one behind of the other one. The straight 4 is by far the most common cylinder configuration. The 6 cylinders inline and the 8 cylinders A-line are very common in marine applications. This is a typical straight block with the 3 cylinders inline, and those cylinders are wet cylinders because you have a space here for the coolant. You have a space here for the coolant. This is the typical straight cylinder. This is the flat configuration. And this is the V configuration. Very, very common in marine application, in gas and diesel. You remember the most famous gasoline inboard engine used is used for Merc Cruiser, but it's the same engine that the Chevy 350, the Chevy 30i. Also, there are other manufacturers that they use Chrysler and Ford engines. In diesel, there are a lot of V configurations. Caterpillar have excellent example of V configurations. Mack also, and Detroit Diesel